In this tutorial I will show how you can use while loops in LabVIEW. So here in the LabVIEW environment, when you right click on your block diagram, you get this structure palette, and here you have different loops and structures. You have the for loop, while loop, you have case structure, event structure, formula node, flat sequence, etc. In this tutorial we will use this while loop, and when you drag it to your block diagram it will look like this. So this will be the border of the while loop, and everything you put inside the while loop will run as an iteration inside the while loop. Let's go to LabVIEW and see how we can use and create a basic example using this while loop. So we will create this basic example. So here you see the front panel. It consists of two different numeric controls, and then the basic with this basic application is to just compare these two values. If I set 5 here and 5 here, then this boolean should be true according to this logic. So I just compare numeric 1 and numeric 2, and if they are equal, this will turn on, and if they are not equal, this will not turn on. And then this application will run until I click on this stop button. And then you see every code is put into this while loop, as you see here. Typically also include a wait here, so in each iteration the loop will wait here, in this case for 100 milliseconds before it goes into a new iteration. And then the while loop will continue to run until you click on this stop button, and then this while condition will be set to true, and then the while loop will stop running. So let's go to LabVIEW and create this basic example. So now I'm in the LabVIEW programming environment. Here I have the front panel where you create a graphical user interface, and then you can just right click and find proper controls that you can put on your front panel to create your graphical user interface. And then here on the white window, this is called the block diagram, where you create the actual code for your application. So then let's start on the front panel. I will create, just right click here, create two numeric controls, 1 and 2. I choose here the fuse design controls. You can also choose other controls, silver, system, etc. And you can also click here on this, pin this here, and then customize, change the visible palettes, and then here you can also choose which palette you want to include in this this palette that shows up when you right click in the front panel. But I choose to use these fuse design system controls. Then I have two numeric here. I can name this to numeric 1, and this will be numeric 2. And then I will have this boolean. I just use this one. So when these numbers are equal, this should turn on. When they are not equal, it should not turn on. And then in addition I need a button. You find the buttons there also under boolean. You have different buttons. I use this stop button. I just put it here. I make the window a little bit smaller like this. So then this is the entire block diagram, entire front panel, or the graphical user interface. On the buttons you typically find the name of the button here inside the button, so then you don't need the label on top. So then I just right click, visible item, and remove the label like this. So this is the front panel. Let's go to the block diagram. Then I just put them here, and then find the while loop. So then I just right click here under in the functions palette you find the structures, and then you have for loop, and then in our case we will use a while loop. So then I just drag it like this, and then all the objects will be inside the while loop. I can also put, of course, one or more outside the while loop, but only those items that are inside the while loop will run inside the while loop. I can also click on the border, select visible items and label like this. So now I will just compare these two numbers. Then I just right click, find comparison, then equal. Then just wire both to this equals function like this. And then to the boolean like this. So when those two numbers are equal, this will be true. And now we also need to connect the stop button to this condition here in the corner of the while loop. So loop condition, if I right click on it, you can change stop if true or continue if true. So the default is stop if true. So then I just wire this one to this one. And now the loop will stop running when this button will be true. Meaning that when the user click on this button, it will be true and the while loop will stop. In addition, you need this timer or wait symbol as a function. I'll just right click here once more, find the timing, and then here you have different timing functions that you can use. I prefer this one, wait in milliseconds. You can also right click on it, visible items, label, and the name is wait in millisecond. And then I can just on the input right click, create a constant, and then here I can specify in millisecond. And if I select or write 1000, then loop will go into this loop, do this code, then wait for 1000 milliseconds or 1 second, and then do the calculation once more until the user click on the stop button. So now we should be finished. I can just save the code to my hard drive somewhere. Just create a temporary folder, and I call it while loop or something. Of course, you should have a better name for your application. Then I can just run application. So I run it, and now you see 0 and 0 are equal, so then this turns on. If I change it to 1, then this becomes false. And I change this to 1, 1 and 1 are equal, and then this boolean indicator turns on. Then I can change it to 2, then it becomes false, etc. So the code goes into this loop until I click this stop button. So when I now click on the stop button, then you see the execution of the application also stops. So now I can change here, but nothing happened because the program is no longer running. I can also turn on this highlight execution like this. And now let's run the application now with this turn on, this highlight execution. So I click on the run button, and you see now the code goes here, and then continuously compare these two values. Wait for 1000 milliseconds in this case. Wait for the stop button to be true. I can change one of the numbers. 4 and 2 is not equal, and it becomes false. 4 and 4 should be equal, and then this becomes true. And I can click on the stop button, and then you see this becomes true, and the application stops. So this is a basic while loop in LabVIEW. So now you have learned how to create a basic program using a while loop in LabVIEW. So let's take it to the next step. Here is the same program, but I have added an array here. And then you see I have wired the array outside the while loop. And then let's see what's happening when we create something outside the while loop compared to something inside the while loop. So let's also add this functionality to our program. So we start by creating an array here on our front panel. So then I just right click here, select data containers. Here you have different arrays. I choose this one, array. So this is an empty array, and we are going to create an array of boolean. So then I just find the same LED here, put it inside the array, and then I can just drag here to see all the elements in the array. So by default they are all false. So now let's go to the block diagram and then put this outside here. So this is inside the while loop. Just make it a bit smaller, like this. And then this should be outside the while loop. Then I just wire here from this one to the array outside here. In addition, on the border on this green square, I need to right click, select tunnel mode, and then indexing, and then the program is working like this. So let's see what's happening now when I run this application. So run it. 4 and 4 are equal, 3 and 4 is not equal, 3, 3, 3, 2, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 2, 5, etc. And then I stop it. And then you see we are getting all the historical values here. So every time this either becomes true or false, it are stored in this array. So all the different values, when I change the number here and this turns either false or true, these values are now stored in this array either as true or false like this, but it doesn't show any value before I click on the stop button, and then this goes outside the while loop. So this is how you can use a while loop and then show some values after the program has been executed. So when this when you click on this stop button, the while loop stops and then this will be executed. Next, I want to show you how you can use the so-called shift register. So the shift register is found here on the border of the while loop. So then you just right click on the border and create a shift register, and then this will pop up. And the shift register are storing temporary values in each iteration. So in this basic example, I will just have two numbers and add those two numbers and present the answer here in this numeric indicator. So here you see the code for that, numeric 1 and numeric 2. I add them and then put it into the answer indicator, which is here. And then I use a shift register to so here, this is the initial value in the shift register, so then it goes to start. And then inside the while loop I have created a case structure. So then it goes, when the program are starting to execute, it goes into here, put the value start here, and then this goes to the question mark, and if this value is calculate, then this will be executed. If it's start, it will go into another case. If it is stop, it will go into the stop case. So let's see how we can create this example where we use this shift register on creating a basic state machine. So then we are back in LabVIEW. Let's start with creating the front panel. Of course, these are just stupid examples to illustrate the principles with while loops and the functions that can be created using a while loop. Then I start by creating two numeric 1 and then numeric 2 like this, and then a numeric indicator that should be the answer like this. And then we are ready to go to the block diagram to create our code. So then I just have those three here in the bottom. I start by creating this while loop. I put the while loop here. So right click on the border, select visible item. And then now we are going to create this shift register. So then I just click here on the left border and add shift register, and then you see this shift register will be created on the border of the while loop. And then by default this has no data type, so then I just right click here outside the border, select a string constant, and then select, for instance, start. So this will be the first case that we are going to go into. Then I just wire it to the shift register like this. Then inside the while loop, I create a case structure. So then I just right click here, structures, and then case structure. Then just create the case structure inside the while loop. I can also click here on the border, visible items, label, and then case structure. So here we have a while loop and then a case structure inside the while loop. Then I can wire this, the output of this shift register, to this question mark on the case structure. Just like this. And then, since the first case should be start, then I can change the value inside here. So by default it's false or true, so then I go to false, just change it to start, like this. And then here I also wire, so I can create a new, so first we should go into the start case, then I need to calculate the answer for these two numbers. So then I should create a new case. I can use the true case and change the name for it, and then I can just call it calculate or something like this. And then inside here I will create the logic for adding these two numbers. So then I just drag those into the while loop, because everything that is inside the while loop will be executed within the while loop, like this. Then I just right click, find this numeric add. So I will just add those two numbers like this. Just improve the code and then wire to the answer. So now this calculate case has been created. Then I just go back to the start case. I can just copy this one or create a new one. So string constant, I put it here, and then I name it calculate like this, and then wire it to this right border of this shift register like this. And then it should go into this calculate. And finally we can create a stop case. So then I just right click here on the border of the case structure, right click, add the case after, and then I can name it stop. And then the application should stop when you go into this case structure. So then I just right click here again, select string constant, and then here just so here in the calculate, after you are calculated, I want to stop the application. So here I go to the stop case. So I just create it once more. String. Then it goes to stop like this. So now we are almost finished. And then, so now this while loop goes from start, which then it goes into this case. Since here it says start, it goes into the shift register, and then the value here will say start. Then it goes into the question mark on the case structure, and then it will go into the case called start. Here I can do some initialization of this numeric control. So I can create a local variable, for this one. So I can just set the start value to be 0 for both of these. I right click, create local variable. I also set this to be 0, so then I can just do like this. I wire this one down here, and I do the same for the answer. Right click, create local variable. So then I just initialize all these to be 0 when the program starts, and then we are ready to do some calculations. In addition, I can also create a stop button. So then I just go back to the front panel, find a button, this stop button, click the front panel a bit smaller. Then since this is already saying stop inside the button, I just right click and remove this label on the top here. Then we want the program to stop when you click on the stop button, which is here. So first it goes into start, then here I just initialize and set the different numeric controls to 0. Then I go to calculate, and then here I can check. So either here I can go to the stop button, to the stop case, which is here, or I can calculate once more, depending on either this is true or not. So then I can just do some logic here. I can use this comparison and this select, and then here if I click control H, you have 3 inputs in the middle, then you have true false, and then you have, if it's true then you should do this true, and if false you should do this false. So then I just copy this one. So when it's true it should stop, if it's false it should calculate once more. So then calculate like this. So then we have this logic which decides the next case. So then I remove this one, wire output here. So if I click the stop button, it should go to the stop case. If I don't click on the stop button, it should continue to calculate these two numbers and add them and put the answer here in this indicator. In addition, typically you want to have this timer, so I just right click here, select this timer and this wait, and then I just put it here. I can click create constant and 100 milliseconds or something. I can also turn on the label like this. So now we are almost finished. Then we only need to connect something to this loop condition. So typically here in the start, I can here in the start case select boolean, and then this false constant, I can create it here, and then I can wire it to this condition. So now in the start case this is false. In the calculate case it should also be false. I just right click, create constant, and then finally here in the stop case I can also just wire something here. No, this should be true, so I just right click, create constant, and then set it to true. So this means when you are inside the stop case, this becomes true, and then the loop condition becomes true, and the while loop stops. So now we should be finished with our basic application, where we show the principle of while loop and a case structure, and using this shift register, and these things together becomes a state, a so-called state machine. It's a very powerful way of program in LabVIEW. So now let's just go through the basics here. So here we have a while loop, and inside the while loop we have a case structure with 3 cases. Start case that just initialize these numeric controls and indicators. Then it goes to another case called calculate. It just calculates 2 number and check if the button is stopped or not. If it's stopped, it goes to, if the user click on the stop button, it goes to stop. If not, it just do the calculations once more, and then we can change the values. So let's just start running this application. And now 2 plus 2 is 4, 2 plus 3 is 5. I click on the stop button, and then you see the entire program stops as well. I can also turn on this highlight execution, and then now let's see how the flow goes into the program here. So again click, Then it goes here, start, it goes into the start case, do this initialization, go to calculate, calculate these two numbers, check if stop is button is clicked, no, then it goes to calculate once more, stop is still false, then it calculates once more, and then I click on the stop button. Let's see what's happening then. No, this becomes true, and it goes to the stop case, which is here, and then this becomes true, and the loop condition becomes true. So basically, this is a simple application in LabVIEW, where I just calculate two numbers, and I have used a while loop, a case structure, and on the border of the while loop I have used this shift register to control the flow inside the application, and this programming principle is called a state machine.